Hey there friends, in this video we'll be going through this challenging circle question. If you have any questions of the methods I use along the way, please leave a comment down below. I'll do my best to help you out. So let's crack on. Now the goal is to find the area of this sector here, then find the area of this triangle here, subtract the triangle from the sector to get the final area of the segment. So let's begin. So a tangent, which is just a line that touches the circle at one point and that is perpendicular to the radius, has this equation. Now we need to get into the correct form of y is equals to mx plus c, so dividing everything by 2 will give us y is equals to 2x plus 10. Now we can figure out a by just substituting minus 3 into the x here to find our y coordinate for a, which happens to be 4. So a has coordinate minus 3, 4. Now, as I said before, the tangent is perpendicular to the radius of the circle and as well as the diameter of the circle. That means we can figure out equation AB by simply taking negative reciprocal of the tangent gradient, which happens to be 2. Negative reciprocal just means adding a negative sign and putting the whatever number you have to the power of minus 1, which can be represented as 1 over this number. So in this case, it's 2. If we take a negative reciprocal of 2, we get minus 1 over 2. So line AB has an equation of y is equals to minus 1 over 2x plus c. To figure out the c, I'll be using the method y minus y1 is equals to m times x minus x1. So this method is used when you're trying to find the equation of linear graphs. y1 and x1 are just known coordinates. X and y you keep the same as unknown, and m is just the gradient. So in this case, it's the known coordinate. Let's take it as a. So y is 4. Therefore, substituting 4 into this y1 will give us y minus 4 is equals to the gradient minus 1 over 2 times x minus the x1 in this case is minus 3. So substituting minus 3 into the x1 will give us minus 3. That means it's plus 3. So minus 3 like this, which would be plus 3. So expanding and rearranging will give us y is equals to minus 1 over 2x plus 2.5 as our final equation of line AB. Great, now we can figure out the coordinate for B. By simply substituting minus 1 to this y and solving for x, we find that x equals to 7. So B has a coordinate of 7 minus 1. Okay, great. Now we can figure out the center of the circle, which happens to be the midpoint between A and B. Finding the midpoint will just involve doing 4 minus 1 divided by 2 to find our y midpoint, and 7 minus 3 over 2 to find our x midpoint. So to find midpoints, it's just the coordinate plus another coordinate divided by 2. So in this case, it will be 4 plus minus 1, which is the same as 4 minus 1, and 7 plus minus 3, which is just 7 minus 3. So it's 1.5 and 2. So the midpoint or the center of the circle is 1.5. Now using our knowledge of circle equations, we can write out the circle equation here: x minus 2 squared plus y minus 1.5 squared is equals to the radius squared. Now let's try figuring out the radius, and to do that we'll just use Pythagoras. So let's take this triangle here, it's a right angle triangle. We can find the height, we can find the length of the base, and using Pythagoras we can figure out the hypotenuse, which happens to be our diameter. Then dividing it by 2 will give us our radius. So the height is 5 because there are 4 units here and 1 unit here, in total making 5. And the length is 10 because there are 3 units here and 7 units here. In total that makes 10. Then doing the square root of that, of all those numbers squared, will give us the hypotenuse. So square root 10 squared plus 5 squared equal to 5 root 5. Dividing this by 2 will give us the radius. So the radius is equals to 5 over 2 root 5. Great, so the circle equation is just... So now we can finally figure out the coordinate for C. All we have to do is to form another right angle triangle and use Pythagoras. So drawing the triangle like this, we now know that the radius here is 5 over 2 root 5, and we can figure out the length of the base to then use Pythagoras to figure out the height. So we write 5/2 root 5 squared minus 17/5 minus the x-coordinate for the center point, which is just 2. And we square that as well and square root everything. And that gives us the answer of square root 2929/10. Great, so this is the height of this triangle here. Now we can basically add this height to the y-coordinate of the center point to find the c. So the y-coordinate for c. So finally, the y-coordinate for c is just 1.5 plus square root 2929/10. So c has a coordinate of 17/5 and 1.5 plus square root 2929/10. Now let's try drawing the sector. So to find the area of this sector here, and this is the center point, we'll need to find the angle here. Let's call it angle alpha. To figure out alpha, we'll use cosine rule. And to make this work, we also need to find the length BC, which is done again using Pythagoras. So drawing a right angle triangle, then trying to find the hypotenuse by finding the length of the base and the height of the triangle. So the length will just be 7 minus 17/5, squaring that, plus the height squared, which is just 1 plus 1.5 plus square root 2929/10, and square that as well, and all square root to find BC. So BC is equals to square root 1/2 times square root 2929 plus 97. Now, an important point to make, you don't want to round up too early along your question. So I leave my answer as this, because if I round up now too early, I will end up with a slightly different answer from what I should. So I'll leave my answer to the greatest accuracy as possible and leave as an irrational number and carry on working with this. Now finally, we can figure out the angle alpha by using the cosine rule, which, as you remember, is a squared is equals to b squared plus c squared minus 2bc cos a. Our a is bc, and for me not to write this whole thing out, I'll just write it as bc squared is equals to b squared plus c squared, which is just the radii. So b and c are both radii, so really it's just going to be 2 times the radius squared. So it's going to be 2 times 5/2 square root 5 squared minus 2 times, now b and c are again the radii, so b times c, it means just the radius times radius, so it's radius squared, so 2 times the radius squared is just 2 times 5/2 square root 5 squared times cos a. Now rearrange everything to find cos a, and I'll repeat once more, bc is just that, which is roughly minus 0.2089, etc., etc. I'll leave it on my calculator, and taking an inverse cos of this answer will give me approximately 102.0615234138 degrees. So alpha is this number. Great. Now all that is left is to find the area of the sector, which is easy to do. It's just 102.06, etc., etc., divided by 360 to find the fraction that this sector takes of this whole circle, times pi r squared, so pi times r squared, 5/2 root 5 squared, minus the area of this triangle here. And to find the area of this triangle, we will actually use this sine area rule, which is AB sine C over 2. So that's A and B are our radii again. So this is A, this is B, and our C is the angle here. So angle alpha is our C. So radius times radius is again just radius squared. So 5/2 root 5 squared times sine C. So sine 102 ... divided by 2. Subtracting one from the other will give us approximately 12.55 to 2 decimal places. So the final answer, the area of the segment BC, so this segment here, is 12.55 arbitrary units squared to 2 decimal places. And that's it. This is how you solve this challenging circle question. I hope you enjoyed this. If you have any questions, please leave the comments below. Also, support this channel by liking this video and turning your notifications on. You can also join our Discord to find these wonderful revision resources and to get support from one of our excellent tutors. And I'll see you in the next video.